This is higher homework. It's practice paper C. It's the non-calculator paper and we're looking at question 22. So this one looks like a recurrence relations question. Two sequences are generated by these recurrence relations. Okay, the two sequences approach the same limit as n tends towards infinity. Part A is evaluate this limit, and 2 marks for that one there. So what I'll be using is I'll be using the first recurrence relation, and from there I'll be able to work out the limit from that there. So first of all, I'm going to state that since the 0.4 lies in between -1 and 1, I'm going to say that a limit exists. Okay, and I'm going to say let L be the limit. Okay, right, so I'll write down the recurrence relation first of all, and from there what I'll do is I'm going to substitute L into these two places here, and then I'm just going to work through and calculate the limit. So I've got L is equal to 0.4L plus 8.4. So if your teacher has taught you to do it a different way and use a formula, use the formula and work it through. This is the normal way that I would just go forward and do this one here. So what I have over this side, I've got L, I'm going to take over the 0.4, and that's going to be minus 0.4, and what I've got left on the right hand side is 8.4. So remember that's 1L there. 1L take away 0.4L leaves me with 0.6L is equal to 8.4. So L is equal to 8.4 divided by 0.6. And if I need to work that out, what I can do is I can multiply top and bottom by 10, which gets rid of my decimal points, if that makes it easier for me. And then I can divide 84 by 6, and that should give me 14. So the limit of the sequence is 14 as n tends towards infinity. Okay, so that's the limit calculated so far. I can then go on to part B and determine the value of k in this other sequence here. Right, so for part B, let's go for it. We'll go for writing down the sequence first of all. Okay, and I'm just going to make a statement, let L be the limit. Okay, and what I'm going to do is I'm going to take the limit from over here and I'm going to substitute it into two places over here. So remember that would be L is equal to k times L plus 2, and what I'll do is I'll just substitute the 14 into here. So that'll just be 14k plus 2, and what I'll do is I'll take the 2 over to the other side, so that'll be subtracting 2. What that'll give me is it'll give me 12 is equal to 14k. So I'll divide this side here by 14, and I'll just simplify that down. So that should give me k is equal to 6/7, and that's the value of k. I don't need to work it out as a decimal, I'm just going to leave it as a fraction. That's where I'd like to leave that question there. And I can see that that value there lies in between -1 and 1, so therefore a limit would exist for that sequence. Right then, so let's go ahead and see the marking. So I've got 2 marks for A, 2 marks for B. So let's go for, I'm going to go for 1 mark for making a statement that the limit exists, and also can let L be the limit, and just 1 other mark here for letting L equal to 14. For part B, what I'll get is 1 mark for substituting in the 14, and finally 1 mark for getting the k is equal to 6/7. Right, so this question here, just 2 marks for A, 2 marks for B, out of 4 marks, and that's the question complete.